Welcome back to UX203. In Lecture 2 we established how to discover what users need through research and personas. Today we ask, given what we know about users, how do we organize information so they can find it? This lecture is about information architecture, the invisible skeleton of every digital product. We are in Lecture 3 now. Research grounds us in user needs. IA translates those needs into structure. From here we move into visual form wireframing, prototyping, and then the craft of the interface itself. IA is the layer that makes everything navigable. Get it wrong, and the best visual design in the world will not save your product. Bad navigation is not a minor inconvenience. It is a revenue problem. 68% of users leave a website because the navigation is confusing. Not because the product is bad. Not because the price is wrong. Because they could not find what they were looking for and gave up. Studies of e-commerce sites show that up to 50% of potential sales are lost because users cannot find the product they are looking for. The item exists. The user wants it. They just cannot navigate to it. Users have a tolerance of approximately 3 clicks before frustration overcomes motivation. 3 clicks. That is your entire budget for moving a user from landing to goal. Every extra step leaks users and revenue. Information architecture is, at its core, the practice of organizing content so that the right person can find the right thing at the right time. It has 3 components that work together. The organizational system, how content is grouped and categorized. The labeling system, the words used to describe those categories, which must match the vocabulary users actually use, not internal jargon. And the navigation system, the physical mechanism by which users move between sections. IA is invisible when it works. You feel it only when it fails, when you land on a site and spend 30 seconds staring at the navigation, trying to figure out which section might contain what you need. That feeling of being lost is an IA failure. Apple.com is one of the most studied navigation systems in the industry, and for good reason. The Apple navigation contains 7 top-level items. Not 20. Not 40. 7, which is roughly the upper limit of items humans can hold in short-term memory. Within 2 clicks, you can reach any product page on one of the most complex e-commerce catalogs in the world. The constraint is the design. The menu itself is a masterclass in hierarchy. Products are visually distinguished from support and shopping. Mega menu panels reveal depth only when needed. The cognitive load is kept deliberately low, even as the site serves millions of distinct visitor intents simultaneously. There is no single correct navigation pattern. There are 4, each suited to a different content structure and user task frequency. Top navigation works best for sites with a small number of distinct sections and users who are not deeply expert. They need to see all options at a glance. It is the default for most marketing and e-commerce sites. Sidebar navigation is ideal for applications with many sections and users who work in the product frequently. The sidebar externalizes the navigation so users can move between sections without losing context. GitHub, Notion, and Figma all use this pattern. Breadcrumbs are secondary navigation. They tell users where they are within the hierarchy and let them step back. They are essential for content-deep sites like documentation libraries and e-commerce catalogs. Search First works for products with enormous content libraries, Google, YouTube, Amazon. When the catalog is too large for any menu to represent, you give users a direct line to what they need. But Search First fails for shallow products, or when users do not know exactly what to search for. Card sorting is the method you use to test whether your proposed IA actually matches how users think about your content before you commit to building it. Write a set of content items on cards, 1 per card. These should be real items from your product. Page names, feature names, document types. Avoid jargon. Give the cards to participants, ideally 15 or more, and ask them to group the cards however makes sense to them. Do not provide the groups. Let them create their own labels. This is the insight. When you analyze the results, you will find that certain items cluster together across almost all participants. Those groupings are your natural categories. Items that participants consistently misplace or cannot categorize are navigation problems waiting to happen. Use the sorting results to restructure your proposed navigation. Then test the revised structure. More on that in a moment. Validation means running the process until you achieve consistent, Predictable groupings across your participant set. You are looking for convergence, not consensus. Mental models are the internal representations users carry of how a system is organized. When an interface matches a user's mental model, navigation feels effortless. When it does not, users feel lost even if the structure is logically correct. Notion and Google Drive organize files in ways that seem similar on the surface but produce very different mental models. Google Drive organizes files in a flat hierarchy. You can technically nest folders, but the mental model is search for things you can't see. Notion organizes content in explicit nested pages. The mental model is navigate to what you need. Neither is wrong, but they serve different users with different mental models. The lesson: design your IA for the mental model your users arrive with, not the one that makes sense to your engineering team. Notion allows pages nested infinitely deep. You can have a workspace inside which is a team space, inside which is a project, inside which are documents, inside which are subpages. That depth could be catastrophic for findability. Notion makes it work for 3 reasons. A persistent sidebar that externalizes the hierarchy, a powerful universal search that compensates when navigation fails, and user control. The structure is always user-defined, which means the mental model and the structure are always aligned. The Notion sidebar is always visible, always current, and always clickable. Users never lose their place in the hierarchy because the hierarchy is always on screen. Deep IA works when search and visible structure compensate for depth. Tree testing is the complement to card sorting. Where card sorting reveals how users want to group content, tree testing validates whether the structure you built actually lets users find things. Write realistic tasks, find the refund policy, locate the API documentation, navigate to billing settings. These should mirror actual user goals. Present the navigation hierarchy as a plain text tree, no visual design, no interaction, just the labels and their relationships. This isolates whether the structure and the labels work, independent of visual design. Participants click through the text tree to complete each task. No backtracking hints. You are measuring natural wayfinding behavior. Track 3 metrics. Success rate: did they find it? Directness: did they go straight there or explore? And first click accuracy: where did they click first? First click accuracy is the most predictive. If users click correctly on the first step, they almost always succeed. Restructure the problem areas and retest until your success rate reaches 70% or above. That threshold is the evidence-based standard for a navigation structure that is ready for visual design. There is a well-known principle in IA attributed to Apple's early product philosophy. The best navigation is the one users never notice. When structure matches mental model perfectly, users do not experience navigation as a separate activity. They simply arrive at their goal. The interface becomes transparent. That invisibility is the highest achievement in IA, and it requires more research, more iteration, and more testing than any visual design decision you will ever make. 2 documents that look similar but serve very different purposes. A sitemap is a bird's-eye view of where content lives. It shows every page, every section, every subsection, and their relationships. It is a content inventory in visual form. Its purpose is to ensure completeness, that nothing is orphaned or inaccessible. A user flow is a journey map for a specific task. It shows the path a user takes from intent to outcome, including decision points, alternative paths, and error states. Its purpose is to ensure coherence, that the path to a goal is clear and complete. You need both. The sitemap ensures everything exists. The user flow ensures users can get to what they need. Have content groupings been validated with at least 15 participants? Fewer than 15 produces unreliable clusters. Individual variation drowns the signal. Does tree testing show a task success rate of 70% or higher? If not, the structure is not ready for visual design. No amount of styling will fix a broken architecture. Are all category names and navigation labels taken from participants' own words, from research transcripts, rather than internal terminology? If your users call it Help Center, and you label it Support Portal, you have a discoverability problem. Have both card sorting and tree testing been completed and iterated until the success rate threshold is met? Both methods together provide a level of confidence that neither method alone can achieve. Have problem areas been restructured based on test results and retested? One round of card sorting is not enough. Iteration is the process. Navigation is the primary reason users leave a product without converting. IA must be validated with real users before a single page is designed. Otherwise, you are building on a foundation you have never tested. Card sorting and tree testing are the two methods that transform IA from guesswork into evidence-based structure. Used together, they de-risk the most expensive architectural decisions in a product. Labels matter as much as structure. Use your user's own words, taken from research transcripts, not internal jargon. An architecturally correct structure with wrong labels is still unusable. 3 questions to close. Think of a website where you got lost. Was the problem the structure content in the wrong place, or was it the labels words that meant something different to you than to the creator? What would have fixed it? Why might a search-first IA fail for a product with a small or shallow content library? What does a user do when search returns nothing? And how would you convince a stakeholder to delay a launch by 2 weeks to run card sorting and tree testing? What evidence would you bring to that conversation? In Lecture 4, we take everything we have discovered and structured, and we start making it visible through wireframes and prototypes. See you there.